Welcome to your final evening of ACCU 2023 Lightning Talks. I'm delighted to tell you that there is another exceptional selection of 5-minute talks that you'll be enjoying. As ever, the subjects are completely open. We've got again, the whole gamut of code through idiocy. Do you know what? I've even forgotten. It's going to be a surprise to me as well. Hooray. As ever, these are no longer than 5 minutes, and so far no one has yet gone over the 5-minute mark and had to be physically escorted off the stage. Who knows? This may happen this evening. So, this is your cast, this is your rogues gallery for this evening, and yeah. Oh, and because I will forget by the end of the evening, could everyone just give Mr. John Dye a round of applause, because he's been manning this timer every single time. With aplomb. Thank you, John. Very much appreciated. Right, without further ado, no ado whatsoever, Seb Rose.
Thank you. Did you say the middle button? The middle button? The middle button. And there's the timer. Great. So, I've given lightning talks here before. Some of you may have seen this one. It's about ambiguity. I'm going to carry on about ambiguity, but I'm not going to talk about US measures and metric measures this time. But it's going to be about another form of ambiguity. This time, it's about the ambiguity of this product of growth. Is it a fruit or a vegetable? Well, it is a fruit, isn't it? There we go. So we've got that one out of the way. This is a different sort of cucumber, though. So has anyone come across cucumber, the BDD tool? Yes, thank you. Actually, the last time I got kicked off this stage was when people like you were heckling, and that last time I think it was Francis that did it. So Cucumber is a tool that reads some specification of how the system is supposed to work, and then calls code in your system to ensure that it works in the way that you expect it to. This is what the Cucumber core concepts are. We've got features. So feature files is where we write the business readable specification. Cucumber reads this business readable specification. Based on what it sees there, it calls through to your automation code, which is sometimes called glue code, and then that glue code calls out to your application and checks that it behaves in the way that it's expected to behave. So Cucumber, the Cucumber open source project, started off with Ruby. There's a JVM version, there's a JavaScript version, there is a C++ version, though it's not supported, and outside of the core project, there are other implementations or ports of Cucumber. So Cucumber exists in many, many different flavors. And as you'll see here, there's well, you probably can't see because you'd have to squint at it, but you can see the top ones have got green little squares, rectangles at the bottom. That's officially maintained by the Cucumber open source project. The red ones are officially unmaintained. The blue ones are semi-official, and that's a very odd situation. And then we have unofficial ones as well that go along the way. So there's lots and lots of ports of Cucumber because it's a really simple product. All it does is it reads some semi-structured specification and then calls your program. It doesn't actually do anything clever. So we talked about cucumbers being, are they fruit or vegetables? Is this a cucumber or a gherkin? Yes, exactly. What's the difference between a cucumber and a gherkin? I'm not sure, except that gherkins are normally pickled and cucumbers are normally sliced. So anyway, this is gherkin. So gherkin is the semi-structured, business-readable format that Cucumber and all those families of cucumbers that you just saw earlier understands. And if you read it, you can see that although it's a bit stilted, it makes sort of sense. It's something that you might show to your product owner. You might even show it to a customer. So that's gherkin. This is what people get really hung up on. They could think, if I write my tests using this format, then I am doing behavior-driven development, BDD. And if I use Cucumber to do it, then I must be doing BDD because Cucumber was created to implement and support BDD. They're wrong. This is what BDD is. BDD is a set of 3 practices, discovery, formulation, and automation, that get applied in turn sequentially to a user story. So discovery is where you collectively come to an agreement in the team about what you're supposed to implement. Formulation is where you take that collective agreement and you write it out in some form of business readable language so that it persists for the lifetime of the project. If you happen to use Gherkin to write it out, then you can automate it using Cucumber. Now your documentation is not so much self-correcting, but it at least will tell you when it deviates or diverges from the product. So that's the goal of BDD. The goal of BDD is to really understand what you're doing so you don't have to do it more than once, then to document it so that you don't have to go and reverse engineer what it was that you did, and then automate it to make sure that anytime you do diverge from your documentation, the build system tells you. So BDD is not Cucumber, BDD is not Gherkin, BDD is not test automation. Cucumber, SpecFlow, Behave, Behat, they are all things that understand Gherkin. BDD at the end is the same as ATDD, which is the American version called Acceptance Test-Driven Development, just to confuse matters. And then finally, Cucumber is an optional ingredient in the BDD salad. Thank you.
Thank you, Seb. I'm losing this chair. Performance art for you. Okay, what do you call 10 cucumbers in a line? This is topical. Cucumbers. Cucumbers. Come on. Okay, next up is Lucian. Give him a round of applause.
Hello. Hard things, like speaking in public. I gave a talk yesterday about concurrency, and I argued that concurrency is hard. Actually, no, I'm wrong. Concurrency is very hard. But that's not what I wanted to talk about today. I wanted to talk about thinking. I was listening to a favorite artist of mine, which happens to live in Bath nearby. And the song started like I was thinking about thinking, but it really didn't get me very far, which often happens. So I thought I threw a tarot, but I only got a priestess and a star. And I did some research about what does that mean, and apparently it's a combination of spiritual insight and inspired action. You have access to deep intuitive knowledge, and that's the thing that got me somewhere. So what does that mean? What do I get with this deep intuitive knowledge? So High Priestess, well, in my context, I was thinking about software engineering, so my context is maybe this guy over here. Kind of looks like the same picture, right? And the star, well, probably it's referring to this guy who sadly passed away last year. So these two guys together seem to be the inspiration I had. So Brooks argued very famously, software is essential complexity, which kind of made a point of Aristotle by making the distinction between accidental and essential. And that's kind of the fundamental of our craft. It's kind of the fundamental of what we are doing in software engineering. Then Kevin has a ton of talks about philosophy of code, how to reason, how to argue. And I was like, what do you mean, Kevin Henney? And he answered into the same slide, knowledge acquisition. That's even more confusing, like it's even more philosophical and even more thought-provoking. And he says something like, everything that we do is applied epistemology. But, yeah, a new person appeared in this picture. So applied epistemology, like that's the thing that we reason about things, right? So how do we reason about things? And that's the profound thing. And in particular, the question that I'm having is, how do we reason about software engineer? Like, this is an engineering discipline, right? We should be based on facts. And if you ask about what are the facts, it's kind of like, we don't quite have a lot of facts. We just keep reasoning about functions should be small and this and that and BDD and ATDD and blah, blah, blah and whatever. So there are a lot of questions that need to be answered. like how to reason about code, how to reason about complexity, how to reason about software design, how to reason about software architecture, how to reason about processes, testing, and so many, many more. And those are all hard things. So I do like hard things. So what do I do with this list of things? Well, I just created myself a backlog for me to do. And I'm happily accepting volunteers. So if you have any ideas on how to reason about stuff, please drop me a line. Thank you very much.
So, I'm a lecturer now by trade rather than a developer, and I gave you your lecture yesterday. Today is the test. So, what is the weight of the human brain, approximately? 1.4 kilos, very good, well done, you pass, you get a lightning talk. Right, so, I was talking yesterday about how amazing it is that this 1.4 kilos of jelly can do incredible things. And we can do all the stuff that we've been learning about here and loads more, all with this. So I wanted to look back a bit through the history of things we've done with our incredible brains. And agriculture is one of them, but also alongside that, intellectual pursuits. And I said, brain hasn't changed very much actually over thousands of years. So the brain itself, not going to be much different between medieval times and now. So here we've got a contrast between or a comparison side by side of medieval agriculture and medieval intellectual pursuits, which I think you could agree is the kind of thing we do in coding, right? If C++ isn't an intellectual pursuit, I don't know what is. So let's come forwards a little bit, or quite a lot, back to 1970s again. Here's 1970s agriculture, come on a long way, lots of automation. There's a 1970s-ish combine harvester. The intellectual pursuits now, still indoors, still in a specific place. As you can see, other way. As you can see on the previous, on that one, all indoors, all gathered in one place to do that, both to do the pursuits, all gathered in the fields to do the agriculture. On this one, still in the fields to do the agriculture. Still in the building where the machines are, constrained by that. The machine is essentially the field in 1970. That's where you've got to be. Let's come forward a bit to the year 2000, when the entire universe didn't actually collapse, which is quite good. I was part of helping it not do that. So, agriculture, still pretty similar. The automation is still changing things a bit in that the shapes of the bales have changed over the years to these great big round ones, which is a feature of being able to roll them by machine. And the office, so there are things in there that young people might not recognise. There are CRT monitors in there. What have we got? We've got a printer by your desk. There's a CD, and on the side of the desk there's a real men something or other sticker. I don't know what it says, and I decided not to pursue further and look. So, then we come to 2020. And in 2020, agriculture has to stay in the field because the crops have to be harvested. You can't leave the potatoes there to rot. You can't do that from home. So your agricultural workers turn up in the fields with masks, and they continue to collect those vegetables from the fields. Meanwhile, for the intellectual pursuits, the things you need to do with your brain, we can actually get out of there. The offices are empty. People are working from home en masse for the first time. At which point, they rediscover something that was designed before I was even born, essentially the modem. We can work from home, we can work remotely. This was a massive discovery in 2020. Despite, go on button, there you go. I'll leave that one there just for a sec, because this is a brilliant video from 1979, talking about all the marvelous possibilities that modems can provide. I'm not going to show it to you now, because Pete will then manhandle me off the stage and be up against the code of conduct. So do watch that one at your leisure. It's wonderful. So here we are in the 21st century with a machine out in the field. No humans, well, there might be a human somewhere, but no large numbers of people having to turn up in the field to pick radishes. Now, there are whole other issues you might think about with that, but radishes can be picked in that field. The humans don't have to be there. So how come lots of businesses are saying the humans need to be there, when even the radish pickers don't need to be there? Why are we not letting them be in a place where they can use their brain to do the thing that are being paid to use their brain for and find the best possible flow state for them? So that's all I wanted to say about that. While I'm here, and I've got 30 seconds left, I just want you to make a massive, massive, massive round of applause for all my students who are not only at their first conference, but have just totally smashed it, giving their first ever conference presentations. They'd look good up here. Thank you very much to them. You've made me very proud.
Okay, talking about conferences. A bison, a cow, and a swordfish went to a business conference. They were stakeholders. Right, next up is Stefan. Give him a round of applause.
So, hi, I'm Stefan from Germany. So a few speakers talked about ChatGPT already, and I thought I'd give my 2 cents about what I experienced, my unique things. I hope you find it as entertaining as I thought. So maths, I think it has to be improved with math. I asked it, what's the primitive of 1 divided by 1 minus x? And it responded, it's essentially ln 1 minus x. And then it gives a bit of math, deduced it, and in the end, its result is minus ln 1 minus x. It failed to copy its own result into its answer correctly. It lost the minus sign. So when you ask it, it makes follow-up errors then. If you ask what's the integral between 0 and 1, it will give you a negative number, and it has to be positive. And if you point that out, it says, oh, you're right. I made a mistake. It has to be positive. I have to change the sign. So it just cheats to get the real result. It's amazing, not mathematically sound. Facts, we've heard about that before. This is my favorite example. I saw 2 people talking on YouTube about chess, and one said, I heard about Bobby Fischer as a kid in a rap song, but I don't remember the rapper. So I thought, I'd give it a try. Is there a rap song about Bobby Fischer? And sure there is. Bobby Fischer is a song by Loop Fiasco in his album Food and Liquor 2, 2012. It even sums up the content of the song, says here mental health struggles of Bobby Fischer's in there, and guess what? That's a lie, it doesn't exist. The guy exists, the album exists, but there is no such song on it. What it is good at is generating text. I don't like writing emails. I can use ChatGPT to do that. I have a server behind a firewall without access to the public internet. I want to access a specific IP on the internet. Please write an email to the firewall admin to request this access. And this happily does. Dear firewall administrator and whatnot, it's all in there. It even has a passage about, oh, I know about the security implications. So it not only has it understood my request, it also understood the implications and generated a text accordingly. And it is interactive. Next question. Please make it less formal. I didn't like it as formal. And it does so. Hi there, and now it's more friendly. So I could use this with modifications, obviously, and send it as an email. So I thought, this formalness, how can I make it even less formal? And I'd ask it, can you write it in the form of a rap song? And sure it can. So this is just verse 1. Yo, listen up, firewall admin. It has in total 3 verses, 3 times a chorus, and an outro. It's really nice and labeled too. So, oh, fan fiction, please try this. Use ChatGPT. What if we combine Doctor Who and Warhammer 40k? The Doctor travels to the 41st century of Warhammer 40k, write a short story about what happens. And it does. It has everything about Doctor Who, so we see the TARDIS mentioned there. It goes on and on below. The Doctor is at one point asked, who are you? And he responds, well, I'm the Doctor. So this line is in there. Warhammer 40k is represented. It's depicted as a depressing, dark future. We have Space Marines here. Later on, there will be Chaos Demons, and the Doctor fights them off. It's very nice. Do this stuff. It's fun. I asked it, I have a friend. She likes comics about dwarves. Describe a day in her life. And it makes up all kind of things. She works in a comic book store. She has nerdy hobbies. Whoa. Hobbits too. And yeah, describe when a customer enters her shop. Oh yeah, it's describe the scene. And what happens if a dwarf enters her shop and wants her help? Oh, she's surprised. She didn't think dwarves are real, but they have a little adventure. It's all described. And I keep getting back to this example, to this conversation, and it remembers everything. And I just keep adding stuff to it, and it comes up with more and more story. And I call this the Coco Cinematic Universe. Now, yeah, I sent this to my friend Coco, actually. Yeah, that's it. Have fun with ChatGPT. It sucks when you try to get facts because it makes things up. But if you want to make things up, that's wonderful. Thank you.
Thanks, sir. On that topic, I hear they've invented an artificially intelligent Oreo. It's one smart cookie. Next up, Vittorio. Give him a round of applause.
Thank you. Thank you. Okay, goals of this talk. Annoy you, that's the primary goal of this talk. Secondary goal is to teach you something, but mostly annoy you. Okay, aggregate types, what are they? They're either a built-in array type or a class type without any of these things. They must not have any user-declared or inherited constructors, non-public data members or base classes, or any virtual base class or member function. This is an example of an aggregate. Struct person, as a name, as an age. Doesn't matter if string itself is not an aggregate. An aggregate can be composed of things that are not aggregates. Then we have a couple. It's composed of two people, so two objects of type person. That's also an aggregate. What can we do with these things? We can do aggregate initialization, which means we can use curly braces to initialize the members of these types in the order in which they are defined in the types themselves. You can do this with person, with couple, it just works. You can also initialize the person objects inside couple directly with curly braces while you're initializing couple. You know, you can kind of like nest this sort of syntax indefinitely and it just works. This is all stuff you could have done in C as well. You just need to put an equal sign after the name of the object. And this is maybe something a little bit more interesting. You can also omit the braces of the inner objects. This is called brace elision. And basically the compiler is going to figure out that Alice and 35 go to the first object and Bob and 33 go to the second person. So this is something that you can do also with any sort of aggregate. In 20, we now have designated initializers where you can basically use the dot name of a member syntax to specify which members you are initializing. They still need to appear in the same order in which they are declared, but it helps a lot for readability and to skip some of the members if you want. And in 20, we also have this weird thing where you can now do aggregate initialization using round parentheses. So this is totally valid in 20. You can say person P3, open round parens, Carl 60, close round parens, and this will perform aggregate initialization, even though there is no constructor or nothing like that. Okay. This comes from this paper. It's why do we do this? I'm going to show you later, but there are some differences between the curly braces and round parentheses. We do not allow brace elision. We don't have lifetime extensions for temporaries to be more consistent with actual constructor calls. And there is no guaranteed order of evaluation. With aggregates, curly braces is going to be left to right. This is going to be whatever the compiler wants. Why do we do this? Mostly the motivation for this was that emplacement didn't work with aggregates. So if you try to call emplaceback on something which didn't have a constructor, it didn't work because internally, emplaceback tries to call the placement new operator on the type you want to create using round parentheses. So the choices were, do we actually change emplaceback to branch a compile time whether something is an aggregate or not? Or do we do this? But this was deemed as a more general solution because it would also work in the future with user-defined types and so on. Okay. What can you do with this syntax? If you call pushback, you can do it, creating a person. You can use the curly braces, but of course you cannot do the same as emplacement. You have to provide an object to pushback, something that exists. With emplaceback, you can provide an object, but it's a bad idea because it defeats the purpose of emplaceback. You might as well just use pushback. You cannot use the curly braces on their own because you cannot deduce the type of person from just the curly braces, the template deduction issue. And of course, you can do what it's meant to, which is passing just Alice and 35 is going to take these arguments and construct the person directly inside the buffer we're supposed to, avoiding one move or copy operation. And now we get to this. I have a vector of state array int and of 3 elements. I can push back an array using CTAD here. I can push back the curly braces, but of course I cannot just push back the values. And now with emplaceback, I can push back an array. I cannot push back the curly braces list as we've seen before, but I cannot even push back the values. So we did all this work for nothing. We cannot still emplace state array, which was part of the initial motivation of this proposal. So this frustrates me, and I wanted to frustrate you as well. That was the goal in my talk. Why is this happening? Very quickly, because array has a member inside, which is an array, a built-in array. So when you write array into 3102, you're actually writing syntactic sugar for the double braces. It's performing brace elision. But since we mentioned it's not allowed for parents, then that's why it doesn't work in that case. And yeah, there's no way to emplace a state array. Takeaways. Aggregate types, we learned all of these things in 5 minutes. Thank you so much. I have 10 seconds, and enjoy the rest of the conference.
Thank you. Talking about coding, don't you find it odd that to understand recursion, you first have to understand recursion? Next up is Francis.
I've got no slides and no jokes, but I do have a passion. Let me start by asking you a couple of questions. How many of you in here have solar panels? And of those people, how many have batteries to support their solar panels? Okay. Those batteries, I will bet, are run on lithium. What's the problem with a lithium battery? They're great in our laptops because by the time the battery is worn out, we throw the laptop away. We've got a problem coming up because we put lithium batteries in cars, and we expect our cars to last rather longer than the life of a lithium battery. Lithium batteries are rechargeable, but every time you cycle through, the amount of charge it takes goes down. The faster you charge them, the more it goes down. So we're building up for ourselves a great big problem. If you've got solar panels, and you should have, really you should have, my energy company paid me about £2.50 yesterday. They paid me, not me them. Why? Because it was a nice sunny day. But the problem with this is that we have solar panels that last 25 years plus before they have deteriorated appreciably. We have lithium batteries that, with a bit of luck, might last 12 years. We also have the problem of storage for wind farms, solar farms, and so on. And people will sit on their backside and say, well, somebody will fix it. You know, we can have a great big battery store somewhere. The question is, when? And the answer lies in multiple places. First of all, we need to look at battery technology, and it is being looked at. Secondly, we need to look at batteries that actually do not decay as we use them. And we've got those. How many of you know what a vanadium flow battery is? A couple of you. Look it up and find out. Vanadium flow batteries are in production today. They are in use today. The big problem is they're not suitable for domestic use because they are substantially large. The smallest one I could find is 0.75 of a megawatt hour of storage. And that's a large amount. They're not suitable for putting in cars. They're certainly not suitable for putting in your laptops. But they are suitable for bulk storage. And you say, oh yeah, but that's a daydream. No, it's not. My city, Oxford City, already has a bulk storage facility which uses lithium for long-term storage, so it doesn't cycle lots and lots of times. It can be charged up when the electricity is cheap. There's a bulk. And it's front-ended with vanadium flow batteries, which can be charged and uncharged repeatedly very quickly. And the thing about a vanadium flow battery is it doesn't decay. It can go through many, many cycles very fast, and it doesn't decay. So my message to you is, don't sit on your backsides and say, somebody out there ought to fix it, because you can get your own local community to fix it. The technology is already there, but it needs a boot from us, the electorate, the voters. And in order to do that, we need knowledge. Thank you very much for listening to me.
Thank you, Francis. So a man was walking through his local community and he fell down a well. Why? Because he couldn't see that well. Next up is Victor.
All right, yeah, people are helping me. So yes, .NET Framework, this is slides. Interesting 2-3 days of my life that happened last year. Debugging, I was thinking of giving this talk last year, then do this. This year, I've heard .NET Framework was already not supported, so no point, but no, it's alive and kicking, so I have something to talk about. So yes, if you have ASP.NET service still running somewhere, then you might consider updating to newest.NET, but it happens that services breaks and you have to fix them. I look at the logs. What do we have here? An operation on socket could not be performed because of the system lacked sufficient buffer space or because of queue was full. Do bind on sending request to the other microservice. So what's going on? Apparently, yeah, ephemeral ports were exhausted. Looking at netstat or other facilities, plenty of bounded ports. Bound, if you know something about TCP stack, it's not really a status of the TCP, so it's somewhere in Windows, because we're running in Windows, obviously. Process Explorer finally gives us some clues that there are plenty of handles to device AFD, which quick Google search will tell you that it is actually one of the drivers in the network stack in Windows. So what do we do? .NET Framework has peculiar HTTP client implementation where you have disposable object that you shouldn't dispose, for example, but that's another problem. And what happened right now will be my not very well educated understanding. So if anyone in the audience knows better, please let me know what's going on. But garbage collector. Garbage collector, we have memory in blue, number of bounded ports in green, and the line in orange is when too much memory is being used and garbage collector is actually being run. Because it is run when the memory is used too much, and it's actually freeing more than just memory. It's also freeing ports, bounded ports to the application. So as long as you have fewer requests that are memory heavy, you are fine, because garbage collector will run and not a problem. But what if you have a lot of requests that do not use much memory? Then memory is not a problem, garbage collector will never run, and your application will just shut down because you cannot do any more HTTP requests to other services. And yeah, we have a problem. So what can we do? Extending the context, yeah, with most. If fixing an application is not an option, because to give a little bit of explanation, we did have an access to source code, so I could check that there is not a problem in implementation in our application, but we could not have fixed anything in source code actually. So a few proposed solutions: running garbage collector every tea time, performance it, because you don't always need to run garbage collector. Rank it from outside of the application if we detect port exhaustion, hacky. According to Stack Overflow answers, at least it's kind of working, but not always, not a great thing. Actually, thing that I have proposed was just lowering the memory of the server. It's not, the server had too much memory. The end result. Yeah, our operations team was not very pleased with this solution. Risky, who knows what will happen, because maybe. So sorry, Julia, but adding another server was actually a solution here. Not very sustainable thing, but problem solved. However, at the end, the whole problem was because the port were not released when we were disposing the request handlers response fixed this. So, huzzah for the structures in C++. Thank you.
Thank you, Wiktor. So talking about debugging bugs, what do you call a fly with no wings? A walk. Next up is Peter. Give him a round of applause.
Okay, so you can talk about anything at a lightning talk, and I decided I wanted to talk about something boring. Like, has anybody seen this movie? Good. Oh wait, I forgot to fix the title. Has anybody seen that movie? No? Crouching Tiger, Hidden Friend? No, too bad. So let's talk about hidden friends. It's a thing that I think everybody who touches or sees C++ should know about, and most people do, but some people don't. So let's talk about it. What are hidden friends? And why should I care? It's always my first question. This is a new thing, I don't know about it. Should I care? Should I even bother learning this? So let's write a little bit of C++. It's not much, this is all. And there's a bug. Anybody see this bug? We seem to have an alter ego for Jason Turner in the audience. But you're right, it shouldn't be end line. It's also not going to compile. But my compiler is going to tell me what's wrong. And it's going to tell me. Because I passed some invalid operands. I didn't make an O-stream operator. But the compiler doesn't just tell me this. It's like Eat the Cat, if you happen to know him. He's only trying to help. Because there's options. There's so many of them you could have been calling. You could have been calling these. Or these. Or maybe you meant one of these. But they all didn't match because they're for different types. But we've got templates. Like this one. It didn't match because, well, it's got conflicting types, but we could have been matching that. We just didn't. We have more templates to match. There's so many options. But it's hard to understand what's actually wrong because it's trying to list all the overloads. And I'm only showing you parts of this because I couldn't get it in slides because it's the source file of 90 bytes. The error message is slightly over 10 kilobytes. And you're right, I am lucky because I'm using Clang, and Clang is really good at not giving too much detail. So what can we do about this? Well, why does a compiler tell me about all these options? Well, it does so because it's doing overload resolution. It's looking for an operator O-stream, and it's trying to find the one that matches out of all the ones it can find. And there are apparently lots of options, and none of them match. But why does it find all these options? If I could just hide them and only make them findable if they were right, then you wouldn't get this. You'd only get the messages when they were needed, which means that my error message would go down to, well, being readable. So let's hide them. And we hide them with a thing called argument-dependent lookup. And if you're really old, you know this as Koenig lookup. The idea is we're going to use an argument, and the argument is in some kind of a namespace or a class. And your operator is only going to be found if it's going to be using one of those arguments. And if that doesn't work, it's going to look in the global namespace and find the entire mess again. So what we do is we just hide it in the class. We put it in class, we make it a friend, it's now a global function, but the namespace and this function only participates if this class operates in it. Which means that if we're trying to output this type, we're getting this function. If we're not outputting this type but something else, it doesn't even get found. It doesn't end up in your error messages. And this is awesome because it's a friend. And friends can access private members. I can just do everything I need to do. It is free, but it's only findable through ADL. There's no possible way you accidentally call this. And it even works for regular function names. So you can put your own functions in here, your two strings and whatever, and hide those from giant overload sets as well. It's so awesome in so many ways. So stop polluting the global namespace. Use a hidden friend. It's visible when you need it. It's invisible when you don't. Thank you very much.
You didn't see that? Okay, friends. Why did the owl invite his friend over for dinner? Because he didn't want to be owl by himself. Okay, we're nearly there. Next up is Libby. Give her a round of applause.
Hi, I'm Libby. I'm here today to talk about whether smart people are somehow inherently bad at humaning, a term coined by Gail. So I work in the sports forecasting industry. Until relatively recently, I was much more of a statistician than I was a programmer. Applying statistics to sports has certain difficulties involved, and one of these is sampling bias. In traditional statistical settings, you technically sort of design experiments, make sure your samples are representative, et cetera. This isn't so much possible in sports statistics because you're relying on observational data. This means that you have to be very, very aware of the types of sampling bias you might come up against just because you're not creating your own samples. It may not surprise you to learn that I love graphs. So this is, the axes are taken from Gail's talk yesterday. On one axis, we have computing skills, which sort of represents your technical skills, using computers, etc. On the other axis, we have humaning skills. So things like empathy, communication, teamwork, also very important. This graph got me thinking. I think it's often believed that people who are higher on the computing axis tend to be lower on the humaning axis. The example that stands out most to me is people talking about poor experiences that they have with teachers, teaching environments. Things like the teacher was just too smart to be able to teach. They know their subject so well that they've forgotten how to teach it. This implies a kind of causal relationship, kind of the idea that as more and more technical knowledge fills your brain, some of the bits in charge of understanding the perspective of others just fall out. If this were true, you'd kind of have a trend that looks a bit like this. I've made it quite a sharp trend, so there's no one in the world who's any good at both computing and humaning, which I think we know isn't true, but I propose instead that you might be able to see this trend without it actually being the case. So instead, everyone's randomly scattered on these axes. And the reason for this is because of a type of sampling bias. As Gail actually mentioned in her own session, as if you're sort of hiring for a company, you're sort of looking for people who are good at a mixture of both of these. But you'll take a bit of a trade-off. You might take someone who's a bit worse at humaning in exchange for being a bit better at computing and so on. So you end up with a cut-off line, a little bit like this. So if you, say, work, you're above this line. And most of the people you interact with are also above this line. So your sample that you're looking at of the people that you can see starts looking a lot like this. And this looks like it has negative correlation. That's because it does. So technically, it's true. Of the people you interact with, it could be true that generally the people who are better at computering are worse at humaning. However, the important thing is that in this case, it isn't a causal relationship. It's due to who you tend to see in your day-to-day life. This phenomenon is known as Bergson's paradox. I've put a link up there in case anyone's interested in it. It also explains some other interesting observations, like why good books seem to make bad movies. And I think that the thing here is, why is this important? Why is this relevant? I think, for one, if this is a causal relationship, it's quite a sad situation. I'm quite afraid of public speaking. I'd put that on the humaning scale. As I'm standing here getting better, hopefully, at public speaking, everything I've learned about C++ in my brief time as a programmer is slowly disappearing from my brain. Although I will say, if yesterday's panel on the future of the language is to be believed, that might not be a bad thing. In addition, if we believe that this relationship is causal, this will affect our behaviour. What sort of skills we might choose to develop, where we might focus our time. I think it's important to know that we can do both. It's not an either-or. Thank you for listening.
Thank you. So we're talking about humaning communication. What's Thor's favourite method of communication? Norse code. Okay, bringing this down to land, please welcome David.
Hello, I'm going to be talking about long division. Well, really long division. That could be a problem. So, let's keep it easy. We're going to be dividing 2 by 3. We're programmers, so we should probably do that in binary. But it's long division, so we're going to write it in a table. So we've got at the top, we've got the result that we're computing. We've got 2 in the middle, that's the kind of denominator that we're kind of going along with. Numerator, sorry. And we've got the denominator at the bottom that we're going to be shifting across. So obviously, 1 does not go into 0, so the first thing is 0. Now we're going to shift it. That looks a bit odd. Let's keep going. So 1 goes into 1 time, and of course that cancels, and we've got this other 1 to get rid of. So let's put some more zeros in. Now 1 goes into 0 1 time, so we'll take that away, and we've got this 1 that we carry on over. Let's carry it on. We're going to carry it on again and again. I'll have to cut it short. So we get this chain of 1s. And now we want to shift the 3 across again. So shift it across. Well, this is quite easy. 3 goes into 1 time. So we get 1 there. And now we've got 0, shift it across. 1 goes into 0 times. Shift, 1, 0. Again, this could take a while. We'll skip that again. And eventually we get this pattern. And that's quite pretty, really. And it's equal to 2/3. And because we're C++ programmers, we can say it's equal to 2/3. We can override that. So let's make sure it actually acts like 2/3. So we'll take away 1, and this is going to be, of course, this very pretty pattern. It's just 0, 1, or 1, 0 repeating, depending on which end you start from. And that should be equal to 1/3. Well, let's multiply by 3, just to see if this is going in the right direction. So we get this chain of 1s, all 1s, and that's equal to -1. That looks suspiciously like 2's complement. That's absurd. Sorry, obscured. So is this actually useful? Like, who would care about this? Like, why would you need to divide by 3 in like any context? I mean, surely hardware engineers would have developed some sort of system where you'd have to divide by 2 or some power of 2, not a ridiculous number like 3. Anyway, I hope I haven't been too divisive. It's been real. Thank you.
Thank you very much. So not all math puns are terrible, just some. Was that not good enough? Okay, what's a math teacher's favorite kind of tree? Geometry. Okay. Come on. Okay, what do you get if you divide bread by 0? None. Okay, I'll stop now. Okay, let's give a great round of applause to all these wonderful 12 people who spoke. Thank you very much indeed. Okay, finally, who is here at this conference and isn't a member? Sorry? Not applause for me. No. Thank you. More importantly, who's here at this conference who isn't a member of ACCU? Hands up. Okay. This ACCU is an exceptional organization. It's about people who care about programming. Follow this QR code. You can join ACCU for free and get access to 12 digital magazines a year. There are 2 magazines, one called CView, one called Overview. It's free for you because you've joined the conference. Please take this up. It's an excellent organization. That's all I want to say about that. Thank you again. Enjoy the dinner if you are staying for the speaker's dinner. Enjoy whatever you're doing this evening. Have a great day tomorrow, and thank you very much for coming. Cheers.